Alright, so this video is going to try and explain what's happening with collisions a little bit, or the way we're going to do it anyway. So here's the situation. The green represents a brick, the red triangle around the green represents its bounding rectangle that'll be used for collisions. The blue represents the ball, the red around it is its bounding rectangle that represents, that'll be used for its collision detection. So here's the situation. We have this ball that's careening with a dx of 3, so it's moving in the right-handed direction, and a dy of -5, so it's going up. We know from this starting position that it moves 3 pixels over to the right, it's going to collide, and if it moves 5 pixels up, it's going to be somewhere in this range, so it will have collided with the brick object. So let's take a look at that. If we take away the starting position and we go to the final position, this is where it'll end up, sort of overlapping with the brick to that extent, you know. We know that there's going to be a collision that takes place in its next update. It's going to hit this brick. The problem is, if certain things are true, if it is on the corner, you can't always tell which velocity to flip. So maybe it was just traveling up at such a rate that it intersected the brick, and it was coming up and it hit the brick, so it really did hit the bottom even though it made it this far in its single loop iteration. So how do you tell which way you should adjust the velocity? Should you adjust the dx or the dy? Well, you can't tell from this set of information. If all you know is that it overlaps, you cannot make the right choice. So what we do instead is we'll start the ball again. We check two different things. We can look into the future, and we can separate out that future into pieces of information that will be more helpful for us. So the first time we check the overlap of the ball with the brick to see if there are any collisions, we're going to keep its y position the same and only look at its x destination and its current y position to see if there is a collision in the horizontal direction. So if we take away the starting position and we look into the future, but only look into the future in the x direction, here's what we see. We see a collision. And so we can know with certainty now that in the x direction, in the horizontal direction, it has collided, and so we should flip the value of dx from whatever it is to its opposite. So at this point we just do 3 equals -3, or dx equals -dx. We're not done though. We have to make sure that it hasn't hit a corner directly, so that the y direction hasn't collided with brick also. So we'll go back to the start and we'll do a second check. So here's the starting position of the ball, and we can look into the future, but this time we only look into the future with respect to the y velocity. We keep x the same and we look at the y destination. And there it is. There's the y destination. So we know, has it collided in the vertical direction, like in the with the y velocity? No, there has been no collision. So we don't need to adjust the y velocity. And that is the major principle for how you sort out bouncing collisions with this 4 corners collision detection method. And so, you know, we would check the ball with respect to all of its different corners, not just this corner. So in case it was coming from this way, we could tell, yes, it collided in the x direction this way or the y direction this way. We'd look at these corners, you know, we'd look at all 4 corners. So, but this is the general process, to take a current position, a starting position, and to be able to dissect what in fact you should do given the path on which it's going to travel. So the core idea that you should understand is that we don't actually have to look towards the complete future. We can suss out that information or take out pieces a little bit at a time to actually kind of understand what's happening to create that final position or that final collision. So we can understand the process if we kind of separate out the information into its constituent parts and look at it in pieces. All right, and that's at the core of collision detection.